Hi guys, am I audible? Am I audible to everyone? Please write a yes in the chat if I am audible or not. Okay. Hi. So yeah, hello everyone. Welcome to the PCD of today's Leetcode Biweekly Contest. And today we'll discuss the problems A through D. My name is Pradyumn Kejriwal, and let's get started. But before we get started, I will tell you about our all new CP31 sheet. All right. So, for all those who don't know, this sheet encapsulates 31 handpicked problems in each rating from 800 up to 1900, and they are um, specially handpicked so that each problem teaches a unique idea to you. All right. Added to this, there is also a discuss section right here where you can discuss these problems with your peers and everyone on the internet. Basically, a blog. And added to this, every week, 7 to 8 solutions of these problems will be posted on YouTube. So as you can see, already these solutions have been posted, and 7 to 8 will be posted every week. Also, there is a leaderboard section right here where you can compete with your friends and peers. Also, you can connect your code CF account, and this sheet will automatically fetch the submissions which you have made on your CF account, and it will show you that how many problems you have solved and which you have solved. All right. So yeah, let's move on to our PCD now. So the first problem today was this one. It is called many operations to make array sum divisible by k. You are given an integer array nums and an integer k. You can perform the following operation any number of times. Select an index I and replace nums of I with nums of I minus 1. So basically you can decrement any element by 1. Return the minimum number of operations required to make the sum of the array divisible by k. Okay. So the problem says that you have an array. Okay, you have an array of length n, let's say a1, a2, a3 up to an. All right, and you have to make operations, right? You have to do operations, and what you can do is a of I minus minus, that is set a of I to a of I minus 1, right? And it is asking that you have to make the sum of this array, the sum of the all the elements in this array, as a multiple of k. So sum mod k should be equal to 0, right? So you want to make this, and it is asking you that how many operations of this kind do you need, right? So this is a pretty simple question that you can see, like, you want to make the sum as a multiple of k, right? You want to make the sum a multiple of k. So what does that mean? Let's see that what is happening to the sum when you do the operation. Like when you do the operation, that you select an index I and replace nums I with nums of I minus 1, then essentially the sum will decrease by 1, right? When you do sum a of I minus minus, then the sum will also decrease by exactly once, right? And initially, let's say the sum is s naught, right? And if you do the operation c number of times, then your final sum becomes s naught minus c, and you want this to be a multiple of k, right? So what does that mean? That when you divide s naught with k, like whatever remainder you get while dividing s naught with k, you just have to subtract that remainder, right? For example, if k is 3 and your initially sum is equal to 8, so if I divide 8 by 3, then my remainder is 2. So I'll have to subtract 2 from 8. So I'll have to do the operation 2 times, right? So finally the answer is just the remainder of sum when we divide by k, so which is just sum mod k, right? So that's what you have to do in this problem, that just find the sum of the array and take the remainder mod k, and that is your answer. Okay, so I'll show the code. I mean, I just use the accumulate function here. Wait. Yeah, so this is my code. sum is equal to accumulate nums dot begin, nums dot end, and 0. So this is a function that takes the sum of these numbers in the range, and I'll just return sum mod k. Okay, so that's the A. Nice. So I hope all of you understood. Okay, so let's move on to problem B. So today's B was this one: number of unique XOR triplets 1. You are given an integer array nums of length n, where nums is a permutation of the numbers in the range 1 to n. A XOR triplet is defined as the XOR of three elements: nums of I, XOR nums of j, XOR nums of k, where I less than equal to j less than equal to k. Return the nums of return the number of unique XOR triplet values from all the possible triplets I, j, k. A permutation they have given. What is a permutation? So, yeah, what they are saying is, you have permutation. Okay, you have permutation of length n, that is 1 2 3 up to n. Iska rearrangement, like the rearrangement of this array, anything you can get, like n 1 2 3 up to n minus 1, like any rearrangement they can give you, but every number will occur only once in the array, and every number from 1 to n will occur in the array, so the length is n of the array, right? And you can select any three indices like I, j, and k. All right, and find the value of basically array of I, a of I, XOR a of j, XOR a of k, right? So they are asking that over all of these indices I, j, k, what is the number of possible values of this x? How many distinct values can it take, right? And yeah, I did not say that I less than equal to j less than equal to k here, because essentially this doesn't matter, right? You can select any three indices and just keep them in that order, because this XOR function is commutative. So even if you write ai XOR aj XOR ak, or you write ak aj XOR ak XOR ai, that is the same, right? So this condition does not matter. You can simply select three indices, any three indices, and do the operation. You can even select the same indices, right? So now you have to tell them that how many distinct values of x are possible. This is the problem, right? So the samples are what? The samples are like, uh, input is 1 comma 2 and the output is 2. So in this case, what you can do is, you can either take like 1 XOR 1 XOR 1, like the input is 1 comma 2, right? So you can select any three indices, like either 1 or 2 at every place. So either it is 1 XOR 2 XOR 2, or let's keep it systematic. So 1 XOR 1 XOR 1, or 1 XOR 2 XOR 1, or let's say 1 XOR 1 XOR 2, or 1 XOR 2 XOR 2, or it can be 2 XOR 2 2 XOR 2, right? So what is this? This is 1, then this one is 2, then this one is 1, and this one is 2. Like the handwriting is a bit unclear, I know, but you get the point that these are all of the combinations that can be made using this operation. So finally you are getting only two distinct values of x, 1 and 2. So therefore the answer is 1 and 2. So you have to print 2. And for this 312 case, the output is 4, because these four values are possible as follows: like 0 1 2 and 3 are possible. So that's why the answer is 4. Now let's think about this, that how do we solve this. Now first of all, they are saying that okay, they have given you all the numbers from 1 to n. Let's say 1 3 5 4 2. Let's say n equals to 5. Then they have given you 1 3 5 4 2, and you can select any three indices and take XOR of them, right? So isn't that same as saying that you can select any three numbers and take XOR of them? That is the same as saying that, right? That take any three numbers, select any three numbers, and take the XOR of them. So what is the point of this order? Like even if you write 13542 as 12345, then that will be the same, right? Because let's say in this case you are selecting this index and this index. So here also you can select this one, this four, and this five. So it will give you same XOR value. So there is no point in this order, right? There is no point in the order of the permutation that they have given. Only the numbers matter to us. That what numbers have they given that we can use. So basically, only the n matters to us. What is the n? That is the only thing that matters to us, because they have given numbers from 1 till n, all the numbers they have given. So if we know the n, then we can figure out the answer, right? But now let's see how to figure out the answer. Now you see that, like, just observe that this operation that they have given, like, they have basically, you have been given all of the numbers from 1 2 3 up to n, and you can select any three numbers you can select, and take XOR of them. Like, let's say you select the arbitrarily three numbers and take XOR of them. So isn't that very like flexible thing? Like, let's say I tell you that you have many numbers and try to make the number x, then you have many combinations to try, like basically nc3, which is approximately n cube by 6 combinations that you can try. So basically you have so much flexibility to make these numbers. So our first guess would be what? That all of these orbitals are possible. That basically all of these OR values from 0 up to all bits. Like, see, let's say n is of 5 bits. Okay, let's say n is what? 10110. In binary it is this. So in binary, if it is this, then in decimal it is basically 16 plus 4 20 plus 22, right? Let's say n is 22, so it is this. So our first guess would be that all of the XOR, all of the numbers which are 5 digit, like 0 0 0 0 0 0 0 0 0 0 up to 1 1 1 1 1, we would guess that all of them are possible, because the flexibility is too much, right? That we can select any three numbers and they can be same also. The numbers are allowed to be same also. So there is so much flexibility. So we will guess that maybe this is the answer, that all of the numbers from 0 0 0 0 0 up to 1 1 1 1 1 are allowed basically. So how many numbers are these? Like, how do you count these numbers? Let's say there are n bits, right? If there are n bits in the, or let's say k bits in the n, if there are k bits, then these are 2 to the power k numbers, right? How 2 to the power k? Like, this is 0. If it in binary, this is 0 0 0 0 0. In decimal, this is 0. In binary, this is 1. In decimal, this is also 1. Then this is 2. Then this is 3. And what is this number? This number is just 2 to the power k minus 1, right? 2 to the power k minus 1. Because this bit is 2 to the power 1. This bit is 2 to the power 2. This bit is 2 to the power 3. And this bit is 2 to the, sorry, I mean, this bit is 2 to the power 0, 2 to the power 1, 2 to the power 2, and up to this is the last bit is 2 to the power k minus 1. So if you take the value of these bits, it is 2 to the power k minus 1. Like, the sum of all of these numbers is 2 to the power k minus 1. Right. So our final answer would be just 2 to the power k. Like, that's what we are guessing, that it is possible to form all of these numbers which have the same length or lower length than our n. Like, obviously it is not possible that if we have all 5 bit numbers, like, let's say all of the numbers I have till 10110, like from 1 to 22, that is from 1 up to this number, I have all of the numbers. So they are at most 5 bit numbers. So obviously you cannot take the XOR of them and make them a 6-bit number, because it is obvious, right? Because the 6th bit onwards, every bit will be 0 only in the original number. So you cannot make a 6-bit number. But we are hoping that maybe we can make all of the 5-bit numbers. Now, but how do we prove that? How do we prove that we can make all of the 5-bit numbers? That is our question, right? That is our question, right? That, let's say I have 1 0 1 1 1 0. So n is this. So that means I have all the numbers from 1 up to 1 0 1 1 0, right? And I have to make all of the numbers from 0 1 2 up to 1 1 1 1 1, or let's call this 0 1 1 1, like in binary. If I'm writing, so I have to make all of these numbers up till 1 1 1 1 1. Now, how do we prove that we are able to make? We can just find a way to make them, right? Like we can just, like, if I give you that, given a number, this is how you can make it, then of course it is possible to make them, right? So that's what I'm going to do. That I'm going to give you a method to make all of these numbers using the XOR of just three numbers of these, right? Okay. Now, okay, so in the problem, you can take three numbers I, j, and k, and take I XOR j XOR k, right? So if, let's say, all three are equal, or maybe if these two are equal, then what will it come out to be? It will come out to be k. Like, if I equal to j, then this will come out to be k, right? So basically that's how we can make all the numbers from 1 to n. Like 1 to n we can make. How? We can simply put I equal to j. Let's say we put them as 1, right? And whatever we want to make, the number from 1 to n, whatever we want to make, we'll just put that right here. Let's say we want to make x, so we'll put x right here, and we will get x, right? So 1 to n is sorted. Like, we can make all of the numbers from 1 to n. Now what about 0? How do we make 0? Now we can make 0 by using 1 2 and 3. 1 XOR 2 XOR 3. Okay, we can make 0 by doing 1 XOR 2 XOR 3, and I'm assuming that n is greater than equal to 3 here, right? Because if n is 1, then if n is 1 or 2, then the answer we can calculate by hand, right? So if n is at least 3, then we can make 0 by 1 2 and 3, right? So all of the numbers from 0 to n have been sorted now. Like, all of the numbers from 0 to n have been dealt with. And so see, let's, if n is 1 0 1 1 0, then all of the numbers from 0 up till here, they have been made, right? But now we have to make all of the numbers after this and up till 1 1 1 1 1, right? So we have to make all of these numbers also. So how do we make those numbers? Let's think about that. So basically, reiterating, what we have done is we have made all of the numbers from 0 0 0 0 0 up till 1 0 1 1 0, and we have to make all of the numbers from 1 0 1 1 1 up till 1 1 1 1 1, right? These ones we have to make. And how do we make them? We can use the numbers from 1 to n. We can use any number anytime from 1 to n. Like, we can take the XOR of any three numbers from 1 to n, and they can be same also, right? So let's say there is an arbitrary number right here in the between, and we want to make that. Okay, so let's say it is of the form 1. Like, obviously this will be 1, right? If the number is between n and the nearest power of 2 minus 1, then of course the first bit of that number would be 1, correct? So this is 1, and this is, let's say, x y z w. So it is of this form, right? Where x y z w can be anything from, like, 0 and 1. X y z w can be 0 or 1, right? So I will show you how to make this. Okay, so how do you make this? Let's see. So basically what you can do is just take one number as um okay, just take, let's say you want to have a, b, and c. Your three numbers are a, b, and c, such that a XOR b XOR c equals to your this number. let's say this is D, okay, and you want to make D. So you are taking XOR of these three numbers and making D. So what can you do is you can take A as 1 0 0 0 0, right? Just take A as this one. So um, of course this number is less than equal to n, right? We can only use numbers less than equal to n. A, B, C are between 1 and n. That's the constraint, right? So of course this number is between 1 and n, right? Then B we can select as what? B we can select as here 0, X, Y, Z, and not W. What does it not W, or let's say W bar? Like W bar means whatever is the opposite of W. If W is 0, then W bar is 1. And if W is 1, then W bar is 0. So you can select this one as the second one. And let's say C you can select 1. So 0 0 0 0 and 1. So if you take XOR of these three, if you take the XOR of these three, then what will happen? This W bar XOR 1 will make W, right? And all of these have 0. So X, like Z, Y, X, and this will take 1. And hence you have formed D. Like this is the number that you wanted to form. So what I just proved was that all of the numbers which have the same number of bits as your n, which are even greater than n, they can also be formed using the numbers from 1 to n. They can always be formed. Okay, that's what I have proven right here. That if n is at least 3, if n is greater than equal to 3, then we can make all of the numbers from 0 up to 2 to the power k minus 1, where k is like 2 to the power k is the next power of n. All right. So yeah, so therefore our we can just count the number of bits in n. Like we can just count that how many number of bits is n, and our answer would be just 2 to the power number of bits. And to count the number of bits, we can use the built-in function, like built-in count leading zeros. Like the function is called built-in CLZ. Like this is the function. Yeah, so this is the function which is called built-in CLZ. Okay, and what does this count? This counts that how many leading zeros there are in the n. So if I do built-in CLZ of n, then it will count that how many leading zeros there are. So if it is, let's say 10110, then there will be 27 zeros, right? There will be 27 zeros right here, because one int is of 32 bits. It is 32 bits. So 27 zeros there are. So therefore our number is of 5 bits, right? So what we can do is just do 32 minus the number of leading zeros, count leading zeros, and take the 2 to the power that number. Okay, so that is the solution to this problem. And yeah, if n is equal to 1 or 2, then we have to do it by hand. So if n equals to 1, then what we can do? We have just one number, so we have to do 1 XOR 1 XOR 1, which is 1. So we can have only one number. And for 2, the output is given in the sample itself. So for 2, the answer is 2. Okay, so that is solution right here, that we can make all of the possible numbers. So is it okay, guys? Is it okay, everyone? If you understood, then give a yes in the chat. So I'll move on to the next problem. Quick recap. Okay, so see what I am claiming is that, let's say n has k bits. Like n is a k bit number. So let's say 10110. This is a 5-bit number. So k is equal to 5. And we have all the numbers from 1 to n, 1 2 3 up to n, and we can use these numbers and take XOR of three of them to make our number. So what I am claiming is we can make all the 5-bit numbers. So from 00000 up to 11111, we will be able to make all of these numbers using these numbers, like only taking three of them, like a XOR b XOR c. We can use a XOR b XOR c, and it will, like, where a b and c are from 1 to n, and we can make any number from this one to this one. So we can make all of the 5-bit numbers. So the answer is 2 to the power 5. Or if we have k bits in our n, then our answer is 2 to the power k. Except for when n is equal to 1 or 2. In that case, we will just print 1 for n equal to 1 or 2 for n equal to 2. This is a quick recap. And if you want a full solution again, then you can just click on the small YouTube, like, placeholder, and you can drag it back. So like you can rewind the video and see it again. So if anyone has a doubt, like a specific doubt, then they can ask right now. Why 2 to the power k? Like, um, how many k bit numbers are there? See, this is 00000. This is what? 0. Then 0001 is 1, and so on up till we go till 1111. So what is this number? This number, how do we calculate? This is 2 to the power 0th bit, 2 to the power 1 bit, 2 to the power 2 bit, and 2 to the power 3 bit. So this number is what? 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. So which is 2 to the power 4 minus 1. So in general, if I say that I have k bits, then 1111 up to 1, this is 2 to the power k minus 1. So we have all the numbers from 0 to 2 to the power k minus 1, 2 to the power k minus 1. So how many numbers these are? These are total 2 to the power k numbers. So that's why we can make total 2 to the power k distinct numbers. Like we can make all of them. And I just told you that how do we make all of them? That from 1 to n, we can make directly by just taking 1 1 and x if we want to make x. And for greater than n, I just showed you that we can take 1000, and we can take 1, and the third one we can set accordingly. So we can make all of the k bit numbers. So the answer is 2 to the power k. Okay. So I'll move on to the next one now. You are given an integer array nums. A XOR triplet is defined as the XOR of three elements: nums I, XOR nums j, XOR nums k. So basically the same problem as the previous one, but here we are not given that it is a permutation. Yes, Nitin, XOR of three numbers can also be greater than n. Like if you 1 XOR 2, 1 XOR 2 is 3. 3 is greater than both 1 and 2. Okay, so XOR triplet is defined as this, and you have to find the number of different numbers that you can make using the numbers, right? So again, the problem is same, but here we have been given an array. Instead of a permutation, we have been given an array a1, a2 up to an, right? And we have to count that how many x can we make such that x is equal to ai xor aj xor ak, right? And where I can be equal to j and j can be equal to k, like they can be equal as well. So we have to count the number of x which are the xor of these three numbers, right? But here we are not guaranteed that it is a permutation, that all the numbers from 1 to n occur in this set. We are not guaranteed that. Okay, so just first look at the constraints of this problem. They are pretty small. The constraints are that the number of numbers is up to 1500, and also the numbers themselves are up to 1500 only. Okay, so what we can do, so first of all, just observe one thing, that let's say I have one number x1 and another number x2. Okay, and if I take xor of both of them, x1 xor x2, then okay, let's say x1 had d1 bits and x2 had d2 bits, then x1 xor x2 can have at most like maximum of d1 or d2 bits, like whichever one is greater, the number of bits, it will have, it can have those many bits, maximum of d1 or d2. Okay, that is one property right here, that let's say I take xor of 10001 with something like 1010, so this has 5 bits, this has 4 bits, so the xor if I take, it can have at most 5 bits only. Okay, so if I say that my two numbers x1 and x2, they are both less than or equal to n, right? If they are both less than or equal to n, then of course my xor, like my xor will be always less than or equal to 2n. Like why 2n? Because the number of bits in my xor, like x1 xor x2, in the number of bits in my x1 xor x2 has to be, the same as either x1 or x2, right? So it can be at most 2n. So like if I kind of explain why 2n more, because let's say for example x1 is what, x1 is let's say 10000, so it is 16, and x2 is let's say 01111, so it is 15. If I take the xor of these two, so x1 xor x2 is what, x1 xor x2 is 11111, which is 31, right? So even if, like even though x1 xor x2 has same number of bits as x1, like x1 had 5 bits and x2 had 4 bits, so my answer has 5 bits. So even though this x1 or x2 has same number of bits as my x1, but it can be at most twice, it can be at most double, like actually it can't be even double, it has to be less than equal to 2n minus 1. It can't even be 2n. Like in the worst case, it can be up to 2n minus 1, the value of the number. Okay, so if I am taking xor of two numbers, then the value will always be less than or equal to, like this is basically my identity, this is my claim that x1 xor x2 is always less than or equal to 2 into maximum of x1 comma x2 minus 1. So our xor can be up to 2 into max value minus 1 only. Okay, so using that fact, we can basically see here that since the nums are up to only 1500, and even if I like take the xor of two numbers or three numbers, it cannot exceed 3000. Okay, like if I take XOR of two numbers, like let's say I have two numbers x1 XOR x2, XOR x3. Like let's say I have three numbers and they are all less than equal to 1500, right? So at max I can take that my upper limit is 3000. That is 2 into n. That this XOR value will always be less than equal to 3000. Okay. So now at this point I just need to count that how many XOR values are possible between 0 and 3000. That in 0 to 3000 how many XOR values are possible, and I have to print the count of that, or I have to return the count of that, right? So is it clear till here, guys, that the XOR of three numbers, if all three of them are up to 1500 only, then the XOR of all three of them will be up to only less than 3000. So we have to count between this range, that how many XORs are possible. Okay, so guys, do you get this part? Okay, so now if this range is very limited, right, this range is very small, so we can actually iterate over this range. Like let's say I want to figure out that I can I make the XOR as x, right? Like I will iterate through the entire range, I will vary x goes from 0 to 3000, and in this loop I will check that is it possible to make x, is it possible to make x, right? And then I will just print the number of possible values. But now how do I figure that out? Now one more observation here is that the length of this array, that is the number of numbers, is also very small. It is up to only 1500. So we can do n square in that also. Like if we run a nested loop twice in the array position, I can basically do that. Like it will not give TLE, right? So let's say I do that. Now, how do I use that fact to my benefit? I can simply store all of the pairs. Like I can store all the values that AI XOR AJ. Like if I do AI XOR AJ, like if I take any two numbers from the array and I take XOR of them, then which values can I make? Okay, I am trying to calculate this first. That if I iterate, like if I take any two numbers from the array, let's say my array is a1, a2, a3 and a4. So if I take any two numbers from the array, then what values of XOR are possible? So if this is equal to x, then what values of x are possible? And I know that the only possible values will be between 0 to 3000. Like this range is also very small, so I can basically keep a vector of bool. Like I can keep a boolean array of length 3000 and store true there if it is possible to make this XOR value using two numbers. And like how do I figure out that it is possible or not? I can just iterate over the entire array. Like I can just do for I equal to 1 to n, and for j equal to I to n, I will do possible of ai XOR aj equal to true. Like I just iterate over the entire array in n square complexity. Like I just iterate over all of the possible ordered pairs I comma j over the array, and whatever XORs are possible, I mark them as true, and I can keep this boolean array of 3000 length, right? So at this point, what do I have? I have all of the possible values of ai XOR aj, right? But now, but I what I want all of the possible values of ai XOR aj XOR ak, ai XOR aj XOR ak, and I want this to be equal to x, and I want to count that how many x are possible, right? So if I rewrite this like um, a of I XOR a of j equals to x XOR a of k, I can write this, right? So basically, let's say I want let's say I want to check that for a certain x, that is it possible to make this x using three numbers of the array. Then what I can do is I can just iterate over this ak, like I can iterate over k from 1 to n, and I will check that is it possible to make this x using this ak value. See, what I'm saying is that if I want to check that am I able to make a certain value of x or not, then of course it if x has been made, then we have used three values. So I will check for each k from 1 to n that can this ak make x, and can it, and how do we check that? Basically what we want that x XOR ak should be some ai XOR aj. That means that x XOR ak should be possible using two variables, like our initial boolean array which had all of the numbers which were possible using just two numbers from the array. We will look up that, we will look up our answer in that ki, if x or ak is possible to make in ai or aj, then my x is possible. Like if for any k, if for any k I am able to find that ai or aj, like if x or ak is possible using just two variables, then I can use three variables and do ai or aj or ak. I will explain this in example only. So let's take the sample test case 6789, or let's yeah, okay, or let's take three length example. So let's say 345. Okay, so this is the array. Now what XORs am I able to make using two numbers? Okay, so up till 10 it is possible in the worst case that I make. So 0 1 2 3 4 5 6 7 8 9 and 10, right? So initially all of these are false, or I'll make a cross there, or let's assume that all of these are crosses. By default they are false. Okay, now iterate over the entire array, and basically iterate over all the pairs. So one pair is this, then this, and this. So there are three pairs, right? So this 3 comma 4 gives what? 3 XOR 4 is 7. So 7 is possible. Then 3 XOR 5, 3 XOR 5 is what? 3 XOR 5 gives 6, right? So 6 is possible. And 4 XOR 5, 4 XOR 5 is what? 1. So 1 is possible. So using two numbers, this 1, this 6, and this 7 is possible, right? Now what I can do is, now I can iterate from 0 to, like, okay, this is my array which depicts that which numbers are possible using two numbers. Now but I want the answer for three numbers, right? So for three numbers what you can do is just do this, that just check that, okay, let's say from 0 to 10 For each number, I want to check that is it possible to make using uh, three numbers or not. So let's say I want to check that is one possible, right? So if one is possible using three numbers, then it has to be either, okay, wait, there are more values possible also. This zero also possible, because 3 comma 3 is also a valid pair, so 0 is possible, right? So 0 1 6 and 7 are possible. And now let's say from 0 to 10, I want to figure out that which values are possible using three indices. So I can iterate over from 0 to 10. So let's say I want to check if one is possible or not. So to check if one is possible, I will iterate over 3 4 and 5. I will check, can 1 be made with 3 as a third number? Like, can 1 be made with this XOR 3, right? And if that is possible, then that means that this number should be possible using two numbers. So basically, I want this XOR this should be equal to 3 XOR 1, and 3 XOR 1 is 2, right? But 2 is not possible, right? 2 is not possible. So that's why I cannot make 1 using 3. But now let's check with 4. Can I make 1 with 4? So for this to happen, I have to have that XOR of two numbers should be equal to 5. So do I have 5? I don't have 5. So I cannot make using 4 also. And can I make 1 using 5? And the short answer is no, because for that we need 4, and we don't have 4. So therefore we cannot make 1 using three numbers, right? So like that's what you can just do for all the numbers from 0 up to 3000. We can just find out that for every ak, is it possible to make x using ai XOR aj XOR ak. And to do that, just find if it is possible to make x XOR ak, right? So I'll show the code first and then I'll take your doubts. So my code is here. Okay, so this is the code. I have this pos vector of boolean, which is a boolean array of from 0 to 3000. Okay, and this pos stores all of the numbers which have like which can be made from two numbers, right? So for int I equal to 0, I less than I plus plus. For int j equal to I, j less than n, j plus plus. And pos of num size or num j equals to true, right? And then I have new pos. So I'll iterate over I equal to 0, I less than equal to 3000, I plus plus. And what I am doing is that is new pos equal to true or not. Like if I find such a number such that it is possible to make i's or nums of j. So basically for every I am iterating over this j. What is this j? That what is the third number which I take. So if it is possible to make i's or third number, or i's or nums of j, if it is possible, then I will say that it is possible to make I from three numbers. So new pos of I equals to true. New pos stores that which numbers are possible using three numbers. Okay. And then finally just return the count of true in new pos vector. Okay. So that's my code. Like what I have done is I have done it in n square. Like this is n square loop, right? And this one is basically 3000 into n, so which is essentially n square. So I have solved this problem in O of n square prime complexity, and like I don't know any better solutions like in O of n or O of n log n, but n square is acceptable because the constraints are low. But n cube is not possible. Like if you are talking about brute force, so brute force would be n cube, right? So n cube is not possible because 1500 into the 1500 to the power 3, 1500 cube, maybe divide by 6 also, but that is also not very fast. Okay, because this is essentially uh, like approximately what it is, like I guess 5000, 5 into 10 to the power 9 divided by 6 or something like that. So this is why it won't work. Intuition behind proof of second. So intuition was that, see, the intuition was that um, like it is pretty simple. Like we are given numbers from 1 to n, right? 1 2 3 up to n, and we have to make some number, some random number which is greater than n. All right, so 10110. So let's say n is this 10110, and we have to make let's say 11010, right? So I just took three numbers, just three random numbers, such that XOR of them would become this. And the only condition is that they have to be between 1 to n. 1 is less than equal to a, b, and c, and less than equal to n. And they can be same also. So this is a very loose condition, right? So what I'm trying to do is I'm trying to make this bit as 1. And to do that, I'll just take 10000, because this is guaranteed that it is less than equal to n. And for the other numbers, I can take anything which have 0 here, because they will definitely be less than equal to n. So that's why I just use that. But I cannot use 00000, because that is 0, which is less than 1. So that's why I just used 1. Like I just essentially what I did was I just took 10000 as one number and 00001 as the other number, and the third number I will just take according to these two numbers and what I have to make, and definitely it will lie between 1 to n, because this bit would be 0 and this bit would be 1. So that's the intuition here for that proof. Okay, so is C problem clear? Okay, as it is clear. So I'll move on to the problem D. Okay, problem D is shortest path in a weighted tree. You are given an integer n and an undirected weighted tree rooted at 1 with n nodes numbered from 1 to n. This is represented by a 2D array edges. So edges have been given where ui, vi, wi means that there is an edge from ui to vi with the weight of wi. You are also given a 2D integer array queries of length q, where query is of two types. One type of query is one UV dash that update the weight of the edge between u to v to w dash, where u comma v is a edge. Okay, and the second query is that compute the shortest path distance from the root to the node x. Okay, this is the problem, that we have been given a tree of n nodes which has a root at 1. Okay, so let's say the tree is something like this. Okay, something like this. Okay, so let's say I just numbered these nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Right, and the edges also have weights. The edges have some weight. Okay, so I'll give them weight also. So let's say this is 5, this is 3, this is 2, this is 6, this is 1, this is 8, this is 0, let's say this is 3, and this is 2, and this is 10. Okay, so this is my tree, and we have to compute, like, there are two types of queries. The first query is that we have to update the weight of some edge. Okay, like we have to update the weight of any edge. That is one query. And the second query is that we will be given a node x, and we have to find the shortest distance between node 1 and node x. So let's say the x is 8, let's say, for example, x is 8. Then we would have to print this path length, like from 1 to 3, and then from 3 to 8. So the answer would be 13. Okay, so x is equal to 8. So that's what the problem says. Now this is like a very standard problem. Like if you have studied trees, that is, like if you have studied Euler tour of trees, like this is called by many names. One is Euler tour, or second one is flattening of tree. All right, so if you have studied either one of these, like this is the same topic, just the name is different. So if you have studied this, then this problem would be pretty elementary for you. And if you have studied range queries, like if you know about point update range query, then I think this problem would be like pretty elementary for you, or you might have even done it beforehand. So yeah, like if you don't know about these concepts, about Fenwick tree or segment tree, or Euler DFS, Euler DFS also it is called Euler DFS. So if you already don't know about these topics, then I encourage you to learn about these beforehand, and then look at the solution, or rather let and then try the problem by yourself. And then also, if you are not able to do it, then look at solution. Okay. So now I'm assuming that you already know about this Euler tour and segment tree, all right, or Fenwick tree. So let's see how to solve this problem. Okay. So let's see. Let just take this tree only. Okay. Or let's make a smaller tree. Like let's assume this is a tree. 1, 2, 3, 4, 5, 6, and let's say this has 7 and 8 also. So this is my tree. Okay. Now if I flatten this tree, that is, if I write its traversal, the post order traversal, or let's say pre order traversal, if I write, then what will it happen? So I am in 1. So first 1 will occur, then I'll go to 2, then 3, then I'll come back, then I'll go to 4, then I'll go to 7, then I will go to 8, right, and then I'll come back, and then I will go to 5, and then I'll go to 6. So this is my traversal order for this tree. This is the DFS order, right? So let's say you were told to okay, in this topic, what is the first elementary problem? Like something like that, there are values written on nodes. Let's say there is 5 written on 3, 6 written on the fourth node, and so on. There are values written on each node, and in one query, either you have to update the value on each node, like on some node x, you have to update the value of x of the value, or you have to calculate the total sum in the subtree of the values. Like this is one problem which is very popular, that two queries that update the value of x, they update the value of x to v, and the second type of query is calculate the sum of values of x. Sum of values of x is subtree. Like basically all the children in subtree of x, we have to calculate sum of values of that, right? This is one very popular question, and the way to do it is you can simply keep, like you can simply make this dfs order, right? Simply make this dfs order and also write the values in this order. Like let's say the value of 1 was 3, then value of 2 was 8, value of 3 was 7, value of 4 was 0, value of 7 was 6, let's say, value of 8 was 11, and so on. Just write the values in this order only. So you have this new array, right? 10 and 9, let's say. So you have this new array which corresponds to the dfs order in the tree, right? And then let's say you want to find the answer to a subtree. Let's say you want subtree of 4. Okay. Like the query second type came, query of second type came, and you want the value of subtree of 4, right? So what you can do is just find the range sum. Like you want 4, 7, 8, right? So this entire subtree will be a contiguous segment in your DFS order. Like this 4, 7, and 8 is contiguous. You want this 4, 7, 8, so this is 4, 7, 8. And basically you can compute the t in, the in time, and the out time for all the nodes, right? And using that you can just, like let's say you want the answer for 4, then what you will do is the t in for 4 will be this. Like if I have time in 0 indexing, then this is time 0, this is time 1, time 2, time 3, 4, 5, 6, and 7. So the t in of 4, t in of 4 in this case would be 3. Like the time at which you go into the 4 subtree, right? And t out of 4, t out of 4 would be equal to um, 5 in this case, or sorry, 6 in this case. Like that is the time where you go out of 4 subtree in the dfs order. So like when you flatten the tree and you find this order and also this t in and t out times, so you can simply use them and find the sum from the range sum from t in of 4 to t out of 4 minus 1, right? So this problem, it is very classical to teach like Euler tour of a tree, and like I mean pretty much that, right? So sum of t in of 4 and t out of 4 minus 1, which is sum from 3 comma 5, the indices 3 comma 5, so 0, 6, and 11, which is the 4, 7, and 8 nodes, which is correct answer, right? So this is how you solve that problem. But now we have to solve for path, right? We have to solve for the path, that what is the length of shortest path from the root to a certain node, like this. So how do we solve this? Now first of all, we are accustomed to keeping the values on the nodes. Like in this problem also, the values were on the node, not on the edges. So what I have done is I have transferred the value of edges onto the node it is pointing to. Like if edge is from a to b, where b is deeper than a, like where b is child of a, right? And there is value of c written on this edge. Then I have given this c to the this node b. Okay, so now the value is on the node. Okay, I have done that, and we have to calculate the answer for nodes now, not for the edges. So just one second. Yeah, so uh, let's say I have one sample. Let's say I take, okay, there is no good sample here. I will make one by myself. One, two. So let's say this is a tree, and I have written the values on the nodes. So let's say this value 2, this node 2 has a value of 5, this 3 has a value of 6, 4 has value of 5 has a value of 3, 6 has value of 10, 7 has value of 12, and 8 has a value of, let's say, 3 again. And of course this root won't have a value because there is no edge which is pointing into it. Like basically the 5 value was on this edge which I transferred to the node. Okay, and now I need to figure out, like in my query I need to figure out the sum on a path. So let's say my query is 8, then I will need to figure out the sum on this path, right? So one nice way to do this is that instead of writing the DFS order like this, like conventionally, what would you write? Conventionally, you would say that the DFS order is 1, 2, 3. So then we have 4, 5, 6, and then we have 7, 8. I actually have written this in DFS order only. Like you go to 2, then 3, then you come back to 4, then you go to 5, and then 6, and then you come back to 1 again, then 7, and then 8. So this is the DFS order. So conventionally you would write this, correct? But what I am saying is, instead of writing just entry points, write exit points also. Like instead of writing this, what you should write is, what you can write is something like 1 plus, then 2 plus. What does plus means? Plus means that I am entering the subtree right now. Okay, so first of all I enter the ones subtree, so I write 1 plus, then I have 2 plus because I entered 2 subtrees, then I have 3 plus, then I exit the 3 subtree, so I have 3 minus. Okay, because I come back from 3, then I will go to 4, so 4 plus, I'm inside 4, then I'm at 5, 5 plus, then 5 minus, then 6 plus, 6 minus, and then we have 4 minus, because we leave 4 subtree now. The entire 4 subtree has been done. Now we leave 2 as well, so we'll have 2 minus, then we enter 7, so 7 plus, then we enter 8, so 8 plus, then 8 minus, and then we have 7 minus, and then we have 1 minus. So this is the final DFS order, right? Just try to observe it for a minute, that how I wrote this, that whenever I am entering a node subtree, I am marking it as plus, and whenever I am uh, going up from it, going out from it, I am marking it as minus. Okay, so that's what I have done. And basically the T in and T out correspond to this. Like since 1 plus is at 0, that means the T in of 1, the in time of 1 is 0. Let's say this is 0, 1, 2, 3, 4, 5. So since T in of 5 is 5, like since 5 plus is at index 5, the T in of 5 is at 5. Okay, so I have written this way. Now let's say I want to calculate, this is giving me a bug. Yeah, so let's say I want to calculate the sum from let's say 1 to 6, that this path sum I want. So the answer is what? 5 plus 7 plus 10, right? Correct. But if I did something like add up in this DFS order, like let's say I just wrote it conventionally and added up the DFS order, then I would have the value of these nodes as well. Like if I just did, I have written somewhere. Yeah, so let's say I had just written the DFS order of this tree conventionally, which is 1, 2, 3, 4, 5, 6, 7, and 8. So this is the DFS order, and I want to calculate the path till 6, right? So let's say I just naively take the sum from 1 to 6. Like, so that wouldn't work, right? Because here the value of 3 also comes, the value of 5 also comes. But we don't want those nodes because we have already come out from those nodes, right? We just want that these 4 nodes should be there. So that's the problem, and that's why I have also marked the exit points. So in this case, if I just do a prefix sum from 1 to 6, like there is 6 plus right here, right? So if I just take this prefix sum from 1 to 6 plus, so here what we can see is that I entered 1, so 1 plus 2 plus 3 plus, then 3 minus. So these two cancel out each other. Like since we came out of 3, we come across 3 minus also. So these two cancel out each other. Then we have 4 plus, then we have 5 plus, and then we have 5 minus. So these also cancel out each other, and then we have 6 plus. So essentially, in this prefix sum, we have only 1 plus, 2 plus, 4 plus, and 6 plus. And that's what we need, right? So that's what we can do. We can just write these nodes in the order that we are traversing them, in the DFS order. And we write when we enter a node, and we also write when we exit a node, and we just mark their t in and t out times, like the time in and time out. And what does time in and time out mean? Like time in of 1, time in of 1 means that at which index is 1 plus, 1 plus kahan pe hai, that is the t in of 1. And t out of 1 means that where is 1 minus. Okay. And let's, if we want to make the query for 6, that we want to um, find the sum of all values on the path from 1 to 6, we can just take the prefix sum, like from 0 to t in of 6, t in of 6. Okay, like basically till 6 plus, t in of 6 means that till 6 plus we can take the prefix sum. So that's how we can handle the queries. Like I have made an array of length 2n in this order, in which I'll keep the values. Like I won't keep the nodes in the array, I will just keep the values, and I will make a Fenwick tree out of that, or a segment tree, so that I can take the prefix sum efficiently. And whenever I want to update a value, like whenever an edge is updated, let's say that this edge, it was initially 5, right? But let's say it in a query it gets updated to 7. So I have to update this value to 7 as well. So in the segment tree, I will update this 2 plus, like wherever the t in of 2 is. At t in of 2, I will update 7. And at t out of 2, I will put minus 7. Okay. So initially there was 1 and minus 1. But now if I want to update 7, I will update to 7 and minus 7. Like at this 2 plus, I have 1. And at this 2 minus, at 2 minus, I will have minus 1. Okay. So that is the solution here. So Is this clear to everyone who already knew the Euler 2 concept? Or like, do you get the idea of the Euler 2 concept now? The idea is just that any subtree of the tree, like if I have a tree and I write its DFS order, then any subtree of the tree will be a contiguous segment, like from here to here, let's say. In the DFS order, it will be a contiguous segment. So I can use range query techniques on that segment. But that was when I have to find the value in a subtree. But if I want to find the value of a path, like if I want to find the value from the root to a path, let's say from here, from the root to this node, then I can just make the DFS order a little bit differently. That I will mark the entry points also, and I'll mark exit points also. And at the exit points, I will keep minus v, like where v is the value of the node at, like the value at 2, I'll keep minus v at 2 negative and plus v at 2 positive. And whenever I am taking the prefix sum of this thing, it will just give me the sum on this path. Okay, so I hope it is clear to all. Like, do you all get this modified version of Euler 2 tree or Euler DFS? So I don't see any doubts. So I will show the code, and yeah. So this is the code. Uh, I have this Fenwick tree right here. Look, this template of Fenwick tree, or I'll show in the VS Code only. Yeah. So I have this template of Fenwick tree. Okay, which like which has facility of update. Like at some position you can add a value and a query. Query means some of the values, like the prefix sum of the values. It will do both of these in log n time. Okay. And then what I do, like I just do, like first of all I have this edges vector, right? So out of these edges I make an adjacency list. I make an adjacency list where I push back adjacency of x naught minus 1 dot push back x1 minus 1 comma x2. So basically for UVW edge, I do adjacent of u dot pushback v comma w and adjacent of dot pushback u comma w. And why minus 1? I am doing minus 1 because I am taking all the nodes in zero indexing. Like I am using zero indexing for all the nodes. So I am doing minus 1 to make it zero indexed. Alright. So I am storing both the child and the edge weight. Okay. And then I have made a Fenwick tree of size 2n because my this entire thing, like every node will have one entry and one exit. So if there are n nodes, then it will be of size 2n. So I have this 2n size Fenwick tree, and I have my answer. So the answer to the queries, and then I just do DFS of 0 comma minus 1. This DFS does all the things that it calculates the t in, the t out, and the depth, and also it assigns the value to the childs. Like whichever one is the child, it will assign the value to that. So how it is working, I have this global variable called ti, which is the current time, and whenever I'm entering a node, I just do t in of v equals to ti, and then ti plus plus, and then like I'm calling dfs on the children, and before that I'm assigning the value of like the edge. This is the child comma the weight of the edge in the v adjacency. So I am assigning value of x as y, and then I'm calling dfs on x. So essentially what I'm doing is I am doing t in of v equals to time, then time plus plus, then calling the dfs on all its children, and then going out of the v. So I am doing t out of v equals to time. Okay, and then I just make a Fenwick tree using this t in and t out order. Okay, so initially this Fenwick tree contains all zeros. All right. After doing DFS, I have the t in and t out times, and then what I do is I just insert the values into my Fenwick tree. So for node I, like I'm iterating over all the nodes, I am putting value of I at t in of I, and negative value of I at t out of I. Yeah, sorry, this should be t out of I. I submitted t out only. Yeah, so I updated, like I put value of I at t in I, and minus value of I at t out I, and then whenever I have a query, let's say query of type 2, query is of type 2, that it needs the sum of the values from the path from 1 to x, then I just take the prefix sum from um, 0 up to t in of query 1, and actually plus 1 will also be there because it is open interval. Like this function takes in open interval, but I want up till t in of I, or t in of query 1. Okay, so ans dot pushback ft dot query t in of query 1 plus 1. So like I am taking the prefix sum, and for the update query, I will just like x, y, and v. So on the edge from x to y, I have to change the value to v, and I'm assuming that x is the lower one here, and if it is not, then I will swap x and y. So basically I have to update the value on x. On the node x I have to update, so I'll do ft dot update t in of x of v comma val of x, v minus val x. So what does this mean? This update function basically adds a number to any index. So to t in of x, I want to make the value of v, right? But initially it was initially it was val of x. Initially it was value of x, and I have to make it v. So I have to add it by v minus value of x at t in of x, and at t out of x I have to add val of x minus v, because initially it was minus val x, and now I want to make it minus v. So I just do the update in the Fenwick tree, and finally I also update the val array that I have. And yeah, this is the solution for D. Also there is one more solution like which uses range update and point query. Like actually it is quite easy to think about as well. Like let's say I have this tree, right? So I have this tree, and I want to find that from 1 to x, what is the sum of values on that path. Like this is what I have to maintain, right? So let's say I just maintain the answer. Okay, like let's say I have the DFS order. I have the DFS order. Like it will be something. Or let's take a proper example. Let's say this is node 1, this is 2. Let's say this is my tree. So my order is what? 1, 2, 3, 4, 5, and 6. So so let's say I want to calculate the path sum. Like let's say the values here are 4, 5, 3, 1 and 2. Okay. So I will write, actually what I'll do is, in my segment tree, okay, in my segment tree I will write, um like 1 will have 0, right? 1 does not have any value, so I'll treat it as 0. Then 2 has 4. So like for a node x, I will actually write not the value on x, I will write a sum of values on x. Like for 3, what I'll write is 4 plus 5. Like for 3, I will write 9. So basically, I'm just writing my answer only on my nodes. Okay. So this is alternate solution. Like up till here, what we discussed, it was my solution, and there is one more solution that can be there, that we are basically storing the actual answer in our segment tree. Okay. So for 5, the answer is 1, and for 6, the answer is 2. Right. So this is what I have stored. And of course, the query is O of 1. Like if I have, like if I want to answer that what is the path length from 1 to x, then I can simply look up the table, right? Simply look up this table and I'll have my answer. But what if I want to update? Okay, what if I want to update a node? So let's say I want to update this 2. I want to update the value of 2 from 4 to 5, let's say. From 4 to 5, I have to update this. Correct. So that, what does that mean? That means that all of the nodes which have 2 in their path, they will be increased by 1. Like since I want to increase the value on 2 by 1, then all of the nodes which have path from root to that node containing 2, they will all increase by 1. So what does that mean? That all of the nodes in subtree of this 2, subtree of this 2 will increase by 1. So basically, all of the nodes from t in of 2 to t out of 2, they will increase by 1. So I'll increase all of them by 1. So it is basically range update. Range update. And our query is just what is the value on certain node. So it is point query. Okay. So for this, we can use a segment tree to do it efficiently. Okay. So yeah, this is the solution for D. Like this is one more way you can do it. And yeah, that's about it for this problem D. Now I'll take your doubts. Thank you, Anshul. How to be intelligent like you, and how to come up with solutions on my own. So Dipanshi, the only way, like there is no secret to this. I think everyone else whom you might have asked, they will have told you, they would have told you, I guess, that solve a lot of problems. Like that's what I do. I just solve a lot of problems, and using them I learn, and also my thinking improves. Like if you can see, I have solved many problems. So that is one reason why my like solving skills are pretty good. So like I'm solving these problems. Like if you can see, my recent submissions, these are all like 2100 up to 2300. So these are all 21, 22, or 2300, these recent problems. And why I am doing that? Because my rating is like about 2000. So basically you should practice problems which are uh, your rating plus around 200. Like that's what I do, and that is why I'm able to solve problems on my own. Like I'm able to come up with solutions because I have a lot of practice. Like if you see this problem, it is actually marked as lead code hard, but if you give it to any CM, he will tell the logic in like just 1 second, because this type comes many times. Like this is just standard problem. This is Euler tool problem, and it is a very basic one. So that's why with practice it comes. Like even if it is not a standard problem, with practice you can develop your thinking capacity. Okay, and that's how you can solve problems. So yeah. Anyways, so if you all don't have any doubts, then I'll take your leave, and thank you all for joining in, and I'll see you guys next time. Bye bye.